Here's an example for you to try. Start by writing out the system of equations in x, y and z that are represented by this augmented matrix, and then have a go at solving it by row reduction operations that we've seen. Pause the video and have a go at it yourself, and then I'll go through the solutions. Okay, from the first row we have x minus 2y plus 2z equal to 1. From the second row we have 3x, no lots of y, and 1 lot of z equal to minus 1. And from the third row we have 2x plus y minus z equal to 0. I'm going to start off by swapping rows 1 and 2. And the reason that I'm going to do this is that there's a 0 here, and I don't want to lose it when I start doing row reduction operations. You probably didn't swap those two rows, and so the steps that you applied in your method will be different to mine, but you should get the same result in the end. So the last row stays unchanged, and the first two rows are swapped. We now take the pivot element from the first row, and we use it to get zeros down the rest of the first column, below the leading diagonal. The first row isn't going to be changed. We have row 2 minus a third of row 1, and we have row 3 minus 2/3 of row 1. I'll now swap the second and third rows. This isn't necessary, but remember that I'm going to be eliminating this element here next, and I'd rather use the 1 to eliminate the minus 2 than try to use the minus 2 to eliminate the 1. It'll just make the fractions easier to deal with. Using the pivot element in the second row to eliminate the value below the leading diagonal, we're going to need row 3 plus 2 lots of row 2. The first and second rows aren't changed, but in the third row we've now got our 0 below the leading diagonal. We've achieved upper triangular form now, but we'll continue and we'll use the pivot element in the third row to get zeros above the leading diagonal this time, in this column here. We want row 1 plus 3/5 of row 3 and row 2 minus row 3. The third row isn't changed, but in the first and second rows we've now got our two zeros here. At this stage we want to multiply the third row by minus 3/5 so that we get a 1 here, and we can read off the result for z directly. That gives us the result here, z equals minus 8/5. Normally we would want to use the pivot element in the second row here to eliminate the value above the leading diagonal. We've already got a 0 here, so we don't have to do anything with that step. So we'll just go ahead and we'll multiply the first row by a third to get a 1 here, and then we'll be finished. We now have all 1s on the leading diagonal and 0s everywhere else, and the results for x, y and z can be read off from the right hand side. We have x equals 1/5, y equals minus 2, and z equals minus 8/5. Even if you applied different steps to me, you should still find the same results. If you haven't found those results, then the likelihood is that you've made an algebraic slip somewhere, probably a mistake with the fractions. You can always check your answers back in the original equations to make sure that they do satisfy them.